Hey everybody, it's Spaceful435 and I'm here again with just yet another tutorial. Today I'm going to be showing you how to create an Android and also desktop and also web browser game using the popular library called libgdx. I've got a lot of requests personally asking to create a tutorial on how to create games using it because I've created all of my Android games using the library and I highly recommend it to anyone that wanted to do any type of Android game development. So I'm going to show you how to create a basic Space Invaders game similar to the one that I've created in various other tutorials. So I'm going to get you started on getting set up and downloading libgdx and downloading the ADT bundle pack, which is the Android version of Eclipse, and I'll get you set up with all that. So to get started, first off, I'm going to create this video in just one video. So for one, it's going to be very long, as I'm sure you can tell, and for two, I'm going to try and go fast to keep it down as low as I can. So if you find that I'm going too fast, just pause the video and then just write down or do whatever you have to before continuing. So to get started, we're going to download libgdx. So we're going to type in libgdx on Google and just go to this first link here, and you can probably even just go to download. Alright, so go to download up here. And you can download the latest release, or you can download the nightly builds. Nightly is the newest updated versions of it, except it's not official, whereas the latest releases are the official versions. So it really doesn't matter which one you download. I'm going to do the release just to be stable. Now once that's downloading for you, I'm not going to download because I already have it. Just make sure you have it somewhere. This is mine, for example. These are the different files which should be inside of it. You might have some, or you might not have some that I do, like this projects folder, but I'll get you set up with that later. Next thing you want to do is you want to go back to Google and type in Android SDK. This is going to be the SDK pack that I was talking about. So this is going to give you the Android version of Eclipse that Android gave to you. So when you click on that link, just go to download the SDK and save it to your desktop or wherever you want to somewhere. Just make sure you can get to it pretty easily. So once you've done all that, you should have two folders. You should have the Android Eclipse folder, or it should probably be named some weird letters and numbers combination of them, but it should look something like this. So if you go to Eclipse, you just want to open that to get it opened up, of course. But beforehand, if you guys want to run a virtual Android device, you want to open up the SDK manager, and you're going to want to download the different versions and software updates of the Android software. So what I'm going to have you download is of two different types of software, two different versions. So I'm going to have you download 4.3, which is Jelly Bean, and you can download 4.4, which is KitKat, except most of the new phones don't even have it. The S5 does, the S4 does, the Notes do, and I think the new HTC One has it as well. But I mean, overall, Jelly Bean should be fine to use. So what you want to do is you want to checkmark 4.3, and then also checkmark 2.1, which is kind of like a lower version. So checkmark both of those and just click Install Package. So make sure those are installed. Once you're done that, open up Eclipse, and you should have a blank workspace or just the workspace that you're in already. It doesn't really matter, honestly. Let me exit out of that. And then what I want you to do is I want you to open up the libgdx folder that you downloaded earlier in the beginning. So I want you to run this gdx setup UI.jar file. And what this is it's a UI that libgdx provides to us to help create a project for libgdx very, very easily. It's very helpful. It's a great idea. I can't stress how helpful this is compared to some of the other engines that are provided out there. So when you click on Create, first thing you want to do is you want to type a name for your game. So I'm going to name it Space Invaders. And you're going to want to give it a package. It really doesn't matter. I'm going to name mine com.youtube.invaders. Doesn't really matter. Next, the game class. I'm going to name it main game. What you can't name it is you cannot name it just main. Reason being is because libgdx already has a class in there called main, which pretty much starts the whole application. And if you do it like that, it will give you errors when you import the projects. Now I want you to uncheck the iOS project down here because it'll give off errors to the other projects as well for some reason. And also, before we create that, go to the libgdx folder and create a new folder and name it projects. I already have a projects folder here, so I'm going to delete that. But in here you can store all of your projects like I do, so you can see I have a bunch of different projects in here. Then I'm going to name a new folder called Space Invaders. You'll see why I'm doing this to keep them organized in a second. So once that's done, go back to this UI, go to this little folder, click that, then go to the projects folder you just created, and then to the Space Invaders, whatever you named it, and just click open. Once that's done, go to open generation screen and click launch. It'll take about a second or two, and it's done. So we can actually just exit out of there, and if you go to that folder, you'll see 4 different folders. So the Space Invaders folder is the code. It's where we're going to put all the code for the game. The Android folder is going to be the Android version of the game. Desktop's the desktop version. HTML is the web browser version. So that's done there. Now go back to Eclipse and go to File, New, File, Import, and then Existing Projects into Workspace. Go to Browse, and then browse that libgdx folder where you saved it. I'm going to go here, then Projects, then Space Invaders, and I'm just click OK. Now you'll see these 4 folders pop up, which we just created, and just click Finish. You may see an error pop up here. This error is generated. It's very confusing to work out. There are different tutorials online which can help you get it working. But overall, I'm not even going to create it for that. If you want to, you can look it up online and how to fix that. So the first thing I want you to do is I want you to go to the Space Invaders desktop, go to Source, go to the package, and then go to Main. Here I want you to change a few things. I want you to change this to true, and what GL20 lets you do is pretty much in GL10 or 1.0, when you use pictures that you would load up, they would have to be powers of 2. So they have to be either 2, 4, 8, 64, 128, things like that. So they have to be a certain power of 2 to be able to actually load them onto the game. So if you had a picture of 50 by 50 pixels, it would not work. It would throw an error for you because it's not a dimension of 2. So you're going to have to, or a power of 2. So you're going to have to click true for that, and then go to Android, Source, Package, Main Activity, and just do the same thing there. Click true. And then pretty much we can close these back up. So now we're going to get into the creating of the actual game itself. So the first thing I'm going to do is I'm going to go to the Space Invaders, go to Source, and then go to the Package, and then go to Main Game. Now in here you'll see some generated stuff. I want you literally to delete all of this. You can keep it if you want to and try it out, but I want you to delete all of it except for this batch right here. I want you to delete everything here except for the batch in here as well. And here we can keep these 2 here. I'm going to comment out this for now, and then I'm going to have you delete that, and we'll leave this for the render, and everything else we'll just leave like that. Now up top I'm going to have you create 2 variables, public static int. It's going to be integer width and height. Now I'm going to create mine portrait style, so you can do the same if you would like to. I'm going to make the width 480 and the height will do 800. So it's going to be kind of vertical. If you actually run it right now, it will show you the screen. Actually, before we do that, go to Space Invaders, go to the Source, go to the Package, go to Main. Right where it says the width, type in main game.width, which is the variable we just created, and main game.height. So that'll automatically change the value that we have. So now you can go run, click Java application, just run that. Then go to main, which is right here, and should pop up. So this is going to be our game so far. This is what it's going to look like. Now if you run this on your phone, it should be a black screen similar to that. So that's that right there. Now there's one problem when it comes down to Android products and just mobile devices in general. Every single device has typically a different dimension size, so one might be 800 pixels by 480, or one might be 1200 by something 720, who knows, but pretty much if we were to keep this height and width at 800 and 480 and it was run on a phone that was 1200 by 720 or something similar to that, the picture would be completely out of whack. It wouldn't be to scale. Half of it would, or the game would only be at half of the phone. So you have to be able to make it so that each phone sees the game the same way, including tablets, the computer itself. So if I were to extend this, then it would. If I were to make the window bigger, it would have to keep it to scale. So one of the things they offer is an orthographic camera. But I also found a very helpful, very helpful, give me a second, code online, which pretty much is a camera that makes your life very easy. So let me go to my, engine really quick that I created. Give me 1 second. Alright, so I have two files here. There'll be a link to the source code on here. I just want you to drag these. Actually, before we do that, go to this folder here, go to the source folder, click on that, and click on the package, new Java package, click on that, and at the end just type .camera. We're going to kind of keep it organized here. And then inside of that, drop these two, or type in these two different files. Now get some errors for now, but don't worry about that. What they do is it's pretty much going to make it so that when the dimensions are changed, it's going to keep it so that it's going to keep it at the same aspect ratio. So it's going to keep it just the way it should look on every single device, regardless of the size of the actual device itself. So it's throwing me errors. The reason it is because we have some things here. I'll change this in yours. I'm going to do main game.width, main game.height. This is coming from my game engine, so it's kind of throwing it off a little bit, but that's okay. Ignore this part right here. This should be set for you already, so don't worry about that. If it's giving you an error up here, what you have to do is delete that, click over here, and then click add package declaration, and then it'll automatically do it. Or you can just type it in manually. So as you can see, it's in the package com.youtube.invaders.camera. So package com.youtube.invaders.camera, and that should work for you. Should be no more errors. Now you also have an import error, so just delete these two. If they're there for you, it might not be. Same thing here, so you're going to have to change it. Just do change package declaration or type it yourself, and it should have no errors anymore. So we will use that camera in a second. Now when it comes down to screens, if you want to switch a screen, say you have 4 different screens. So you have a main menu, an about menu, which comes from the main menu, you have a game menu, and then you have a settings menu. It's 4. It's very, very easy to get caught up in code where instead of having to paste it all or render everything right in this one main game.java file, instead of having to do that, we want to keep it object-oriented, organized, try and make the code look nice. So that's what we're going to try and do here. So we're going to delete this right here for now. What we're going to do is we're going to create a system that's going to give us pretty much like different screens that we can run off of. So we can switch screens, change them to what we need with them. And libgdx does provide a screen system, except I'm not very fond of it. I mean, you can use it if you want, but personally I'm going to create my own. And it's very simple. So as you saw, I created a new package. I'll redo that for you. Click on that, go to com, our new package, then just add .screen at the end. Inside of here, create a new class. I'm going to name it screen. And we're just going to make it an abstract class, so different classes can implement or extend this class. And we're going to do public abstract void create. Oops, that doesn't need to be there. Public abstract void render, and we're going to have to pass in the sprite batch, just because we're going to keep the sprite batch the same, just because it's much easier that way. Don't have to create like 500 of them. Next one is we're going to do public abstract void resize int width, int height. Might be a float. Let me double check on that. No, it's int here. So I'm going off what these are right here. We're going to do public abstract void dispose, public abstract void hide, public abstract void create. We actually don't need these two here. I'm sorry about that. Just keep these 4. Now what I pretty much did there is I created 4 different abstract methods that can be implemented by the different screens that are going to extend that class. So as you can see, it's very similar to these. We have create, we have dispose, render, and resize. We don't really have to worry about these. Actually, we probably should in case you want to pause your game later on. So we're going to do public abstract void pause and public abstract void resume. So libgdx automatically calls all of these different functions here. So pretty much we're going to use the screen system and just call whatever screen is running their own version of the method itself. So it's kind of hard to understand or explain right now, but you'll see what I mean in a second. So after that, go back up here, create a new class, go to screen manager. So this is pretty much going to manage the different screens that we're on. We're going to make it an abstract class, or I'm sorry, a static class, because we need to be able to access this regardless of what class we're in. It kind of makes it a hassle to have to pass it around to every single class on the actual code itself. So we're going to make an instance of the screen class. We're going to do private static screen current screen, and we'll just make that null for right now. We're going to do public static void set screen, and we're going to do screen. So we want to be able to set a screen, and this is going to be this dot. Just do current screen. I forgot it's not it's a static. Current screen equals screen. So that should set that. Now before you want to do that, we want to call dispose. So we're going to do current screen dot dispose. So it's going to dispose of everything in that current screen that's running before we create the new one. Once we set the new screen, we're going to do current screen dot create. So it's disposing of the screen that we're currently on. We're switching it to the new screen, and then on the screen that was just switched to, we're going to create it. So that's that there. We also want to make it so that if the current screen is not equal to null, so if it's not equal to null, if it's set to something, then we want to dispose of it. So otherwise, it'll throw us an error. Honestly, it's probably all that we need right now. Actually, we need one more: public static void or public static screen get screen, and we'll return current screen. I'm actually going to make this get current screen. I'm sorry. So what this is doing, we're able to set the screen and get our current screen that we're on. Easy as that. Now we're going to go up to main game. We are going to go to the dispose method, and we're going to do screen manager dot get current screen dot dispose. So if this function's called, actually we have to do if screen manager dot get current screen is not equal to null. So if there's something set to it. So what this is doing, when the dispose function is called, it's also going to dispose of whatever screen. Typically this function is called when the application is closed or deleted or whatever. So that's what's going to happen there. It's my phone dying. I'm actually going to copy this line right here, just because we're going to use a little bit more. Right down here, we are going to go paste that line, and we're going to do screen manager dot get current screen dot render, and we're going to pass in that batch. So it's pretty. I mean, I'm sure you can see the pattern here. So in the render method, we want to render the screen if it's not equal to null. So if there's a screen, next we're going to paste that in there again, and we're going to do screen manager dot get current screen dot resize, and we're just going to do width height, and that's called when the screen's resized, the orientation's changed, things like that. Same thing here. We're going to do screen manager dot get current screen dot pause, and last time screen manager dot get current screen dot resume. Oops. Resume. Drink water really quick. All right. So this is set up right now. So if we were to run this, we might get an error. I don't think we should get an error, but we should be okay. So nothing's going to show up because nothing's happening yet. What we want to do is we want to create a new screen. So how about we create a menu screen? So we're going to do menu screen, new class, menu screen. And I'm going to put it into this package here. So I know I'm going to click here, click new class, and go to menu screen. Alright, now here we want to extend screen. Extends screen. And now you're going to see it want to implement all those methods. So if you just put your mouse over that and you just click add unimplemented method, so it's going to implement all those abstract methods that were in the screen class we created. Now I recommend for those of you watching this video, if you don't understand what an abstract method is, or what abstract is, or inheritance, or object oriented, I'd suggest that you go and you learn more about Java before you dive into this, because you'll get very, very confused very, very quickly. So I'm going to show you just for now system.out.println created, just to show you how this is working. Render is going to be here. Resize is going to be here. Dispose, actually we'll just keep these because those aren't going to be called really. So if we go back up to main game and we go to create, after we create the batch, do screen manager get set screen new menu screen, and this is going to you also have to import it. So put your mouse over it, click import, and it should import automatically for you. Now, if we were to run this, what we did now is, let me go over this. We created the batch. We set the screen to the new menu screen that we created. When dispose is called, if it's not equal to null, so if there's a screen set, it's going to call the dispose function. This is just the OpenGL code. Pretty much is going to clear the screen to white. We can change it to black if you want to do that as well. I'm actually going to make it black. This clears the buffer bit, so it's not going to be trolling everything every single time. It's going to clear it so it's not double buffering, so you don't see things dragging along. And then if the current screen is not equal to null, we're going to render whatever screen's set, and when it's resized, we're going to resize it. And then we're going to pause it and dispose and resume of it when that's called as well. So if we were to run this, it should first call create, then call render, and that should be it. So it's quick, but you saw created, resized, rendered. So it's that simple. That's how that works. The screen system is that simple. I personally like it more than libgdx's system, and I just created it myself because I figured it'd be a little bit more easier to understand and use. So now we're going to get into the more interesting part, I guess you would say, of the tutorial. So what I'm going to do is I'm going to come up here and we're going to create a new instance of that ortho camera class that you saw me, or that you put in there earlier. So we're going to do private ortho camera, and the way that it works, let me go into it really quick here. Lots of different things are going on. I can't even explain them all. I personally just downloaded this and ran with it because there's a lot of different things that are happening in the background, lots of different math that go on to make it so that the orientation is kept the same. So this is what you would even see if you went to the orthographic camera source itself. It's just very, very confusing, very hard to understand. But in here, when we create a new ortho camera, it's going to create a new virtual viewport using the using the width and the height that we created. Now in here, the virtual viewport is what gets the width and gets the height relative to the screen width and the screen height, and it finds out the aspect ratio and it stretches or shrinks the picture relative to the screen. So that's kind of what goes on. You don't really need to know anything else other than that unless you are really interested in really what is going on. But this will make life very, very simple for you because it will keep the screen orientation, the screen relative to the game the same for every single device. So we're going to go back to the main menu screen, and when you go to create, we're going to do camera equals new ortho camera. And that's that, so that's simple. One thing I forgot, actually, go back to the screen, and before render, wherever you want, do public abstract void update. For some reason I forgot that. So it's just going to be updating it. Go back to main game. I know there's an error there for now. Go here. I'm going to copy this again. And before the render, just do blah 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 screen manager get current screen update. So it's going to be our update method. So it's going to update every how many seconds, or every single time the function's called. Now let's import that. I'm going to move it up just because I like to see it up here with all the other stuff. That's kind of like the unwanted methods down here. Aren't called too much and aren't too important. So in here you have the update method, the render method, and the resize. Those are your three main. Really, it's just these two main things that you want to use. So come down to resize and do camera.resize. So it's going to resize it. Each time the resize method's called, it's going to keep the picture stretched or shrunk to the size of the screen, so you won't be. So it'll be the same layout for every single tablet and device. Now go to the update method, just do camera.update. And that's going to update and keep the aspect ratio the same as well. So that's that for the camera. You won't see any difference in the game itself when you run it. It's going to be black because we cleared the color to black, or I did personally. It doesn't really matter if you do or not. Now, how about we do some interesting things? We get some textures in here. So what I'm going to do is I'm going to get two of my textures. Let me go here. Let me see if they're in here. I will have these posted for you somewhere so you can save them and download them as well. Alright, so we need the player and we need the enemy. We'll get the player in a second. So I'm going to copy these to my desktop for now. Where'd you go? Oh, right up there. and I'm going to get a player. We actually need the missile as well. Put the missile down here. And where the heck is the player? Alright, 1 second. Alright, for the player for now, we're just going to make a little red dot. No, that's a bad idea. We're going to make it, for now, we're going to make it like this. I don't know where my version of the player went for some reason. Maybe he is here. No. Alright, well, we're going to use those for now. It really doesn't matter. You can always change the pictures at your own leisure. I really don't care. So when you have those 3 pictures, all you have to do is the pictures are held in the asset folder of the Android project. So go to Space Invaders Android, go to Assets. I'm going to delete this data folder. I don't tend to keep it in there. And then take these 3 and just simply drag them into Assets. So now they should be added to the Assets folder, and from here we're going to be able to load them in. So what I typically do is I create a new class, and I will call it Texture Manager. Now in this class, I put it next to the main game, so it's going to be in the com.youtube.invaders package. In here, I simply just load them and create public static texture instances of them, just because it's much easier to use and access. So I'm going to do public static texture. I'm going to do player, which is going to equal new texture, and we're going to do gdx.files.internal. And then we're just going to do, it loads from the asset folder, so we're just going to do player.png. So that should load it if I am correct off the top of my head. Yes, looks like I am. Oops. Let me show you how to import those. One easy way to import is by clicking Control Shift and O. That's how you can import classes easily. But put your mouse over texture, just click Import Texture. So that's that. I'm going to copy this 2 times just to make it easy on myself. And you go to here, name it Missile. Change this to missile, and then go to here, go to enemy, and change this to enemy. So now it should load up. Let's make sure if we run it now, we shouldn't get any errors. If we do, then it means they weren't loaded correctly. Okay, so they're loaded fine. So those are now textures that we can use to run the game. So now how will we put some textures on there? Now before we do that, we want to create another package. So go to com.youtube.invaders, click here, and then create a new package. Go to .entity, and we're going to try and keep it object oriented here. So in here you want to go to click on this new package we created, go to new class, and we're going to name it entity. Now we're going to make it an abstract class. We want the different invaders, I guess you would say, or the enemies and players, whatever is really moving, to implement this entity class, just because it's going to make it more object oriented. We'll be able to organize them easier and things like that. So first we're going to do is we're going to do public entity. We're going to want to know what texture they use. So we're going to do texture. Their positions, we're going to do vector2 post for position. And really that's all we really need for now. I guess we can also actually add a speed. Actually we can do vector2 direction. So we can do the direction that they're moving as well. Now you're probably saying, what is a vector2? Really all it is it's an object that holds a x and y variable, or really any variable that you want to use, but it also gives you different functions that you can use to find the length or distance between different things, the speed. If you want to look into vector2, it's really used in trigonometry. It makes things very, very, very easy and very helpful to use when you're doing different things like gravity, collisions. It's just a very, very helpful thing. So if you want to learn more about vectors, we'll look them up and just do game development vectors. You'll learn a lot of cool things that have to do with them. So now we're going to create 3 new variables. We're going to do protected, texture. What protected does, if you don't know, is it pretty much just lets you use lets classes get access to these variables for the ones that extend. So if the player extends entity, it's going to be able to access this variable here, but no other classes that are outside of the entity class will be able to access them. So we're going to do protected vector2 post comma direction. Now come down here and just do this dot texture. We're just going to set the variables. Post this dot direction equals direction. I'll upload this to GitHub as well, so if you want to just get these classes quickly and easily, you can do that and just follow along. Then we're going to make some getter methods. We're going to do public vector2 get position, and we really don't need to know what their direction is. It's really not needed. What we're going to do after that is we're going to do public abstract void update. So we're going to let them update, and then we're going to do public void render sprite batch sb. So the update method is going to be abstract, so whatever extends this is going to be able to make its own method of it. Just import that. Alright, so import that again. I keep on pressing Control-Shift-O, but I know that you guys are a little bit, or you guys might not know how to use that. So put your mouse over, click Import Sprite Batch. So like I was saying, we're creating a new update methods abstract. The classes that extend entity are going to be able to create their own methods for it, whereas these are automatically created and able to be used. So in the render method, it's going to be universal. So we're just going to do sb.draw. We're going to do texture. We're going to get rid of all this other crap, and we're going to do post.x, post.y. And that's pretty much going to draw it. It's that simple. That's going to draw it at the position of the of what was set. So that's going to be our entity class for right now. We can always come back and change that if we need to later on. But right now we're going to create a new class in that same package. We are going to name it player. And we're going to do extends entity, add the constructor. I'm going to delete this crap. You can leave it all the same for now. Go over it again, click add unimplemented methods. It's going to add that update method for us. Now what we want to do after that is the texture for the player is going to be set to the texture of the player. So instead of having to have people set it, we're just going to set it ourselves in the super calling. So type in here texture manager dot player, and then click comma. So it should look like this now. So it's going to create a new instance of the entity class using this information here. So that's simple. After that, what we want to do is we want to add the direction, or we want to add the direction to the position value. So first thing we're going to do is we're going to implement the delta float. Pretty much what this does is it keeps the frames per second constant, not constant, but it keeps it so that the game is running the same speed on every single device, whether or not one is faster than another. So it keeps it so that every single one looks the same as well. So what we're going to do is we're going to do direction dot mul. Then we're going to do, I think this might be deprecated, but that's alright, gdx.graphics.getDeltaTime. And yes, it's deprecated. Deprecated means, if you don't know what it means it's not really used anymore, it's not recommended to be used. Let me find what it's not. Oh, you know what it is, it's scale. Do direction.scl and then paste in or type in that same thing again. So gdx.graphics.getDeltaTime. So this is going to multiply it by the delta time. And it's actually going to be, I think it's actually going to set it, it's going to return the value of, so direction equals the scaled value of the current direction. So say that you add, I don't know, say the player moves to the left and we add 3. It's going to multiply it by this delta time, by the frames per second, and then we're going to set it equal to the new direction. Then we're pretty much just going to add the position to that. So we're going to do post plus equals direction. Oh, we can't. That's only C++. Post.add direction. So every single time that it's being set, we're going to move it in direction. Now, I'm just thinking now, go back up to the entity class here. Go to somewhere in here. Just do public void add direction for now. We're actually going to do set direction. We're going to do float x, float y. And then we're just going to do direction dot set x, y. Okay. Alright, so what this does is it's just setting the direction variable to whatever direction we set it to when it's called. So this is going to be used for the moving thing. Come back to the player class, delete this. You really don't need this. I don't know why I thought that you do. Now, like I said, every single time this update method's called, it's going to scale it or multiply. It's going to multiply the x and the y value that we set by this graphics.deltaTime. So it's going to make it a little bit smaller. So let me see. Let me think here. I'm trying to think of what the best way to do it is, because if we keep on scaling, it's going to do it constantly. Okay, so what I want you to do is delete that. Go to entity, go to direction, set direction to direction dot scale, and we're going to do gdx.graphics dot get delta time. Alright, so what I was thinking there is when we, for example, if we would call the update method, say that the scale is 2, or say the direction in the x position is 2, and the y direction is 2. Then we scale it by however much the FPS is, say it's 0.1. It's going to move it down a little bit, and then next time the update method is going to be called, it's going to move down even more, and then every single time it's going to keep on going lower and lower and lower. So it's going to actually decrease the speed of our player, whereas we just want to scale it once when it's actually set. So that's why I made it set scales it once the direction's set up here. For those of you that don't know what FPS is, I'd recommend looking into that as well. Really just keeps it so that the game runs at a constant visual speed for every single device that's working or running the game. So this should now be okay. What we're also going to do in the update method is we're going to add in the moving. So we're going to do if gdx.input.is key pressed. We're going to add keys and also touch. So keys.a, so to the left. Then we want to do set direction. We want to move it to the left, so we want to move it minus 300. This is in pixels. I'll tell you why I'm doing this in a second. Minus 300, comma 0. So it's going to move it to the left, 300 pixels. But because we multiply it by that scalar value, I can actually print it out for you so you can see how small it is. It's a very, very, very small value. Probably less than 0.05. It's a very small value depending on how fast your computer device is. So then after that, we're going to do if gdx.input.isKeyPressed keys.d, so to the right, and that's how you get keys. Presses is very, very simple. It's a great thing with the GDX. 300, 0. So we're going to move it to the other direction, and that's that. Now we're going to go to the menu screen. We're going to do, for now, we're going to do private player, and we're going to do player equals new player. Now we have to create the new vector2 position. So we're going to do vector2, new vector2. We're going to do, we want to set it in the middle of the screen. So we'll do, it's 480. We'll do like 470. It's not going to be exact, but it's all right. Then we'll set it at 15. And then we're going to do comma new vector2 0, 0. We're going to just do vector2.0. So what we're doing here is we're creating a new instance of the player at the position 470, 15. So 470 to the right and 15 up. And then we're setting the direction to nothing, so it's not moving anywhere. Then come down here and we want to do player.update. And come down to render, do player.render sb. And that's that. So now, let's try and run this. We might get a little problem, but I know how to fix it. We'll see. Run it now. Okay, sprite batch was never called. That's right. So in each screen, you have to call spritebatch.begin. Now before we do that, we have to actually set the projection matrix. So I'll explain to you what that is in a second. Go to the render method, go to sb.setProjectionMatrix, and we're going to do camera.combined. Then after that, go to sb.begin, and then under that, player.render, go to sb.end. Alright, now what does this do? So the sb.setProjectionMatrix, pretty much what it does is it takes the sprite batch, and it's going to take whatever matrix. A matrix is pretty much a table of values. So you might have something like 0, 0, like an identity matrix is, I think it's 1, 0, 0, 0. And then you might have another layer, another side, 0, 0, 0. You really don't need to know what this means. It's just mostly used for cameras in 3D and OpenGLs, of course. But that'd be like a matrix, for example. Now the camera.combined, what it is, it's a matrix. It's 4 across and 4 down. So you have x, y, z. That's the 4 that go across, and then x, y, z going down as well. What camera.combined does is you'll see in here that we have a few different matrices. We have camera.projection, view, direction. What camera.combined is exactly what it means. It combines all the other matrices, puts them to one, and pretty much gives you this table. Now set projection matrix, what it does is it takes this matrix and it renders based on the matrix. So it's very, very confusing. It's a lot of what's it called? It's a lot of math. I don't know the exact name. lost it in my head. But it takes this matrix and then it renders, OpenGL renders all the pictures, textures, font, everything based off of this matrix. You really don't have to know what it means, but that's what it does in short layman's terms. So that's that there. So then we call sp.begin, so it kind of gets the sprite batch ready for us. It begins it. We can render whatever we need to in between the sp.end and sp.begin. So now if we run it, we shouldn't get any errors at all. So you'll see that the player is all the way over here. Let me see why. Let me go to main game. Oh, because it's 480, I'm at 470. Go to menu screen. I'm sorry, it's 480 divided by 2 is 240. Make it like 230 to center it. Not really going to be centered, I'll be off to the side a little bit. Now run it, and you will see that it's kind of placed in the center. And then you probably see 15. Well, you might say to yourself, well, other games just start up at the top left. Now that's kind of one of the things that's kind of annoying to some of the new people that are using libgdx, and also, I mean, you'll get used to it over time. But really, the x values still start on the left side, but the y values are flipped. They start at the bottom. So 0, 0 is down here at the left, while 480, 800 is right up here. So that's how that works. It starts at the bottom, goes up. So it kind of switches you around a little bit, but you'll get used to it over time. Now if we click A and D, it will move us to the left and the right. Now see that delta value, see how low it is? It's less than 5% or 0.05, like I said. It's very small. So 300 is an okay amount for us. As you can see, it's not moving 300 pixels because it multiplies it by 0.01. If I were to copy this and paste it into Google times 300, it's going to be 4. So it moves at 4 megapixels every second, or every single time you update methods call, or really 5, which is a fine amount. Now you'll also notice that when we press the key, it makes it so it keeps on moving to the left. To fix that, what we have to do is first we want to make this else if. So if A is clicked or pressed, if D is pressed, else if, or actually else, we just want to do set direction 0, 0. So if nothing's being pressed, we want to make it so it stops moving. That's all it's really saying. So now if you press it, it's going to stop when we let go. So that's that there. I'm going to get rid of the printing here in the entity class, so I'm just going to remove that there. But as you can see, it's very, very, very simple to render a picture and then also move it. That's literally how simple it is. It's a very, very short amount of code, and that's one of the great things about libgdx. So that's what we want right now. Next thing we're going to do is we're going to create the enemy class. So go to this package, create a new class, type enemy, and we're going to extend entity, and text message. Pretty much what we're going to do now is we're going to do something similar to the player. So we're going to do first we're going to import all these here, and we're going to do something similar to player. So we're actually going to come over here. We actually just copy this for now. We could put it into the update method here, but it really doesn't matter. So copy this, go back to the enemy class, or just type it in. I'm going to type it, just do post.add direction. That's that. So same thing there. That's really all that we need for the update. And that's really all that we need for the enemy for now. Alright, so sorry about that. I took a little bit of a leave. I went out with some friends for the night. But I'm back now, so I'm just starting off where I was last time. So I think I was just adding the enemies, so we're pretty much done with that. It's going to be the same update method for now as the player, for the most part, minus the moving, of course. So if you run it, there should be really no differences other than being able to move, of course. So how about we make it so that we can add in different enemies? So what we're going to do is we're going to create a new class in the entity package, and I'm just going to name it enemy. Actually, we'll name it entity manager. So what we're going to do is it's pretty much going to handle, it's going to update all of the current enemies on the screen, check collisions between them and the players, and between the missiles, things like that. So let's set that up. So first thing we're going to do is we're going to create a constructor. It's going to be empty for now. Then we're going to do public void update and public void vendor sprite batch SB. So that's that for now. Now what we're going to do is we're going to create an array of entities. So any class that extends this entity class, which is the player and the enemy for now, will be able to be added to this array. So libgdx gives you a great little generic class called array. Good things about this: you won't get the concurrent modification errors. That's a big part. It's also a little bit faster, which I find very helpful. Overall, I just recommend this over array lists. And there's one thing that really changes that I'll show you in a second. We're going to do entities. There's a new array entity. So I'm importing them. I press Control-Shift-O. You can put your mouse over it. Make sure you import this one here, and just double tap that. Now we want to go down here, and we really just want to do public void add entity, and this is going to let us add entities at our leisure as we need them. So we're going to do entities.add entity, so it's just going to add it if we need it. Alright, so then in the update method we're going to create a for each loop, for those of you that are more familiar with it. So we're going to do for entity e in entities e.update, so that's pretty simple. Then we're going to do for entity e in entities e.render, and we're going to pass in the sprite batch. Alright, so that's going to render it and update it. Pretty simple. So we're going to go back to the right now we're actually going to change this. Let me think. We're actually going to I'm going to rename this for now. We're just going to name it game screen. I'm going to do rename compilation unit to game screen. So we're pretty much just going to go right to the game screen, not to confuse you with menu screen and game screen. So right to the game screen, we're just going to make everything work here. So I'm going to do a private entity manager. Now I want a new one created whenever the screen's set. We're going to do energy manager equals new entity manager. Now for the player, we're actually going to take this out of here. So we're going to delete this. We're going to go to entity manager, and we're going to actually put it in here. So we're going to do private final player. I'm going to do player equals new player. And what I'm going to do is I'm just going to copy over the position that starts at and the direction. So I'm going to copy over the constructor, paste it right in there. So that's that for now. Go back to the game screen, just remove everything that's to do with the player for now. Alright, so that's good. So now we're going to come down to the update method. We're going to do entity manager.update, and we're going to do entity manager.render inside of the begin calling. So that's going to pretty much render everything and make it update as well. So we're not going to see anything on the actual screen. Go to main game. I got to change this back to game screen. I'm sorry. Import that. Put your mouse over it. Click import. I click Control-Shift-O just out of habit. Now go back down to desktop and just run it, and it's really not going to show us anything anymore. Reason being is we have to update and render the player as well. So we're going to do player.update, and we're going to do player.render. So now we should get back to where we were a few minutes ago. So we can move around again. Now what we want to do is whenever a new entity manager is created, we want to generate some entities for it. So I'm going to do, in the constructor, we're going to set int amount. Pretty much that's going to be the amount of entities that we want to spawn, or enemies that we want to spawn each time the screen's created. So we're going to do for int I, which equals 0, just a basic for loop. I is less than amount, so as long as it's less than the amount, we're going to start adding entities to it. So we're going to do pretty much, we're going to get some random. So we're going to do float x equals math utils. This is also a libgdx class. Random, it gives you a start range and end range, which is pretty nice. We're going to do, we want to make the x value from 0, and we want to make the end value to the main game dot width minus texture manager dot enemy dot get width. I'll explain this in a second. So pretty much what we're doing is we're getting the x value that we want to set the enemy at. So it's going to be between 0 and also the width of the screen. So let me open up Paint really quickly. Alright, so say that this is the screen here, and say that our 0 is down here, as you know. 0 is down here, and then 480 is going to be over here. So that's where 480 is. So now say that we spawn 480 over here. Say the picture is a little ball. Now the x-coordinate starts down here along with the y-coordinate. So the y-coordinate and x-coordinate of the texture is going to be 0, 0 at this, and say it's 50 pixels wide and 60 pixels high. So that's going to be 50 pixels wide up here and 60 pixels high. So say that we start the range over at 480. Pretty much it's going to spawn it on here, and it's going to draw it to the right because the picture is going to be over here. So it's actually going to be off the screen. So the reason we subtract the width is so that it's only to about here, and then the circle would fit inside of it. So it's not going to go off the screen. That's why that works there. Now we're going to do the same for the y. We're going to do float y equals math utils random. And what we're going to do here is we want to spawn it off the screen so they move down. So we're going to do math utils, we're going to do main game dot height plus we'll do math utils dot random as well. Oh, what am I doing? We're going to do math utils dot random from the height to, we'll do main game dot height times 2. So we want to spawn them up at the top of the screen. Oops. So we want the screen to be here, and then we want to start up here is where we're going to start spawning them, and it's just going to go up. So they're going to spawn on the screen up there. Our player is going to be right here, and then they're going to start flowing down. So they're going to come towards you. So that's going to be pretty simple. So as they come towards us, we're going to shoot our missiles, and they're going to blow them up pretty much. It's a great drawing, right? So that's the x and the y there. So now we're just going to do add entity. We're actually going to go back to the enemy class here. Just double click on enemy. Go to here and delete the texture. So the texture is going to be the same for every entity, or for every enemy in this case. So we're going to do texture manager dot enemy. So just similar to the player as well. And that should work. Alright, so now go back to here and just do actually we'll come back to that. Just do add entity new enemy x comma y, and that should be it. So we should have to import enemy. Whoops, that's right. New vector 2 x comma y, and then we want the direction. The speed we can actually do random as well. So we'll do float speed equals math utils dot random. We'll do 2 as the minimum, and we'll do 5 as the maximum speed. So it's going to be somewhere in between there. So we're going to do new vector 2. We don't want them moving left and right, so we're going to put 0 for the x value. Now for the y value, we want them to move down. So remember how I said that 0, 0 is right here at the bottom, and then 480, comma 800 is up here. Ooh, man, I need to work on my paint skills. So as you go up, the y value goes up. So what we want to do is we want them to move down. So the y value is going to be negative, or the speed is going to be negative. So it's going to be a negative speed. So they come back down. That's pretty simple to understand. So we're going to do negative speed. And let me see, am I missing a parenthesis? Yes, I am. So make sure there's 3 parentheses there, and that should work for us. So now, let's make sure this works. Oops, we have to go back to the game screen. We should set the amount. So for now, we'll do like 10. Spawn 10 of them at once. Let's watch them come down. Alright, so you'll see them coming down at different speeds. Of course, you can always change the speed, the different values around. Of course, as you run into them as well, nothing's going to happen, so there's nothing really to worry about. So let's go back to the enemy class. Now, when the enemy gets down to this point, when it gets down to 0 on the y value, we want to move it back up to the top. Reason being is we just want them to keep on coming down. That way it makes it easy. We want to respawn them or whatever, or recreate another one once they get to the bottom. So what we're going to do is we're going to go down to the enemy. We're going to update, and we're going to check to see if their y value is less than or equal to 0. Or actually, I'll tell you in a second. So actually, we're going to do if post.y is less than or equal to negative texture manager.enemy get height, and we want to, okay, we'll get to that part in a second. Let me explain this. So we're pretty much saying if the y value of where the enemy is, so say the enemy is right here. Alright, say this is the enemy. Now say it's at 0, 0. Now if we were to move it back up to the top, you would see it just glitch back up to the top. So the reason that I said negative texture manager.enemy.get height is because that is going to be up here at the top here. So it's going to be right up here. So once this point hits down here, so once it gets to right here, that's the enemy. Once it gets to right there, it's going to move it right back up to the top, and it's going to make it seamless. So it's not going to be able to see that that's going to happen. And I can demonstrate that to you, of course, as well. So right now, I'll actually just leave it at 0, and we'll come back to that. Now we're going to do, to make it more random, we're going to create a new x value. So we're going to do float x equals math utils dot random 0 to main game dot width minus texture manager dot enemy dot get width. So we're just creating a new x value again, nothing different from what we did earlier. And the reason we're doing this is just going to randomly move them to the left or the right. That's all it's really going to do. So then we're going to do post.set, and we're going to do x, and then we want the y value to be back up the top. So, like I said, I have to stop closing this. Shoot. Alright, so like I said, once the player gets to here, it's going to move them back up to the top. So we want it to be at the top of the screen, which is going to be 800, or it's going to be main game dot height. So we want them to move back up to the top, and we want them to be set to the new random position on the x axis. So that's that there. Now, if we were to, let me just do this for demonstration purposes. I'm going to make it so that it only spawns 1, so we can watch what happens. Alright, let's just wait for it. Hopefully it comes down quick. Alright, so watch as he just jumps back up to the top. See how he just jumped like that? X value is random again. Keeps on jumping. So like I said, that whole smooth thing, I'll get back to the enemy, and we're going to do negative texture manager dot enemy dot get height. So now, let's move below below 0. It's going to be a little bit more smooth. So there you go, a lot more smooth. And when you have 10 enemies going at once or more, I mean, it's not going to be too easy to tell what is exactly happening. So let me show you that. We're also going to bump up. I'm going to bump up this value. So I'm going to make it ×3. Just because I don't want them to clump up too much. You can always make your own algorithm to switch that up, but it's really up to you. So you'll just see them keep on coming down. So pretty much what we're going to do is we're going to check to see, by checking the game over, we're going to see if all the enemies are gone or not. And if they are gone, then it's going to be game over. So let me show you how to do that. So let's create a new void, or new method down here. We're going to do public boolean game over. And pretty much just going to check to see if the game's over. So I'm going to do return enemies, actually, let me see. I'm going to create a new method up here. We're going to do private array enemy get enemies. I'll explain why I'm doing this in a second. Pretty much we're going to do create a new array enemy ret for return equals new array enemy. Now what I'm doing here is I want to get only the enemies out of the entities array. So it can hold, the entities array can hold enemies, entities, players, and anything else we add in. So like missiles, which we're going to add in next. So what we're going to do is we want to split them up and just get the enemies. So we're going to do for entity e and entities if e instance of enemy. So if the class is the instance of an enemy, so if the class is an enemy class and not a player class or whatever, or player object, I guess is the better term to say, we do ret.add e, and that's that. So it's going to add it to the array, and we have to cast it, of course. Let's do enemy e. So it's going to cast it to the object of an enemy, and it's going to add that to the array. So we're just going to do return ret, and that's going to be done. So now we're going to do return get enemies dot size, and what this is doing is less than or equal to 0. It should just be equal to, but just to be safe. So what this is doing is first we're setting a new array. We're creating a new array, instantiating a new array object. We're going to see all the entities. We're seeing if they're the object of enemy or the class of enemy. If they are, then we're going to add them to the array by casting the entity to enemy. Because enemy extends entity, it can be cast that way. So that's what that's doing there. So then we're going to do return it, and we're actually going to use it down here. So we're going to do public boolean game over. If the enemies in the array is dot size, so how many is in there, is less than 0, so less than or equal to. So if there's no enemies in the array. If there's none on the screen, whatever, then it's going to return true. Otherwise, it's going to return false. So that's that there. Now, let's add in the missiles. So we're going to do create a new class in that same package, the ending package, name it missile, and we're pretty much just going to do public void. I'm sorry, we're actually not going to do that. We have to extend entity and import that. Create the new constructor, add the methods, which is the update. Then we're going to do, like usual, post.add direction. I'm going to make this a little bit better. I'm going to take this and I'm just going to cut it. So I'm going to cut this here. Actually, you know what? I'm sorry. Just leave that there. It's just going to be a little bit more easy for you guys to read this way. Now, what we want to do is we want to do. First off, let's get this straight. We're going to remove this. Change this texture to texture manager dot missile, and we want the speed of the missile to be constant for now. You can always change this later on, so we're going to move that there. I'm just going to do new vector 2, and it's not going to move left and right, and it's going to move up, we'll say 6, so it's going to be a fast, well, we'll make it 5. You can mess around with that. It's going to be a fast missile. So it's going to keep on moving up and up and up. Now, I'm going to make a new method, public boolean should remove, or I'm actually going to do check end. And what we're going to do is just going to do return post.y is greater than or equal to main game.height. And what this is doing is pretty much just going to say if the missile is greater than the window, so if it's outside the window, this is going to return true, and this is going to be used for removing the missile from the array that's going to be held from the entities array. So it'll make more sense in a second. Let me just do that. Let's see, we're going to go to entity manager. What we're going to do here is we're going to, let's see if we can pass in a new instance of entity manager in here, just so we have access to it. So we're going to do private final entity manager, and we're going to need this to add missiles. So we're going to do entity manager, actually we have to do this dot entity manager equals entity manager. And then we're going to come down here, we're going to do if gdx.input.is key pressed keys dot space, then we want to fire a missile. So we want to do entity manager dot add entity new missile. We want to make it from where the player's position is. So we want to do post dot add. What this is going to do is it's going to add a little bit to the y value, so it goes up in front of the missile. So we're going to do 0. I can show you that. Actually, I'll show you that right now. So right now it's not going to add anything, but it's going to add a new entity whenever the missile's fired. So if we do this now, it should technically work. Let me make sure this is correct here. Type conda this, so we have the instance of it when we create the player. Should technically work now. Ooh, that's not correct. Give me a second. Let's go to the player. Alright, so what we're going to have to do is we're going to have to check when the last missile is fired, so we don't fire 10,000 missiles all at once. So what we want to do is we're going to do private long last fire. And what we're going to do is we're going to do, put some braces around this. We're going to do, if system dot current time milliseconds minus last fire is greater than or equal to 250, then we want to fire the missile. I'll explain this in a second. Fire the missile and reset last fire to the current time. So what's going on here? So pretty much what's happening is let me fix this. We're going to do post.copy so we don't change the actual position value of the player. So as you saw, when I fired, the person moved up. The reason that happened was because it was moving this position, and giving the missile an instance of the player's position. So they were pretty much sharing position values or vectors, and then as we added to the missile, it also added to the player. So we had to create a new copy of it or an instance of it to create a new version of it. It's going to have the same values, just a new version, and then we're going to do the add 00 for now. I'll explain what that is later. But after that, pretty much what we're doing is we're getting the current time in milliseconds. So in 1 second, there's 1,000 milliseconds. So what we're doing is we're getting the time, subtracting it from the last time. So the last fire is also equal to a certain time in milliseconds. So we're pretty much saying if the difference between them, if the time passed between them is greater than 250 milliseconds or a fourth of a millisecond, or I'm sorry, a fourth of a second, then we want to let them be able to fire. So we create the new missile, and then we reset last fire so that it gets reset up here. So let me show you that. Fires 1, fires, so you can't fire a bajillion times. Now let me show you that without it. So let me just remove the last fire. See how that happens? Keeps on just shooting at little chunks, you can hold it down, just fire a bajillion of them. Yeah, so that's why that's important. Now you'll also notice, when I fire, the missile comes from the bottom left. So you can't really tell, but if I drew the missiles, let me show you that actually. You don't have to do this, don't worry about this. I'm just doing this for demonstration purposes. So if you fire it, you see it comes from the bottom left. That's because it's starting from wherever the position of the player is. So like I said, what we're going to do is we're going to add over the, we'll do texture. Actually, we're just going to do 25 for now, and we will do texture manager dot player dot get height. So we want to add 25, so it kind of fires it from the center of the player, and we want to move it up the height of the player, so it starts at the very top. So now you can see it just starts right in the center and fires. So that's how that works there. And let me go back to the entity manager and just move that down. Alright, so what next? Let's check some collisions, shall we? Alright, so what we're going to do is we're going to create erase some of this. What I'm going to do is going to copy this. I'm going to paste it down here. So what we're going to do is we're going to create a method called get missiles. And we're going to change array to missile. Change the enemy to missile, entity to missile. Change this to M for now, and leave that as M, as entities, I mean. Oh, I'm sorry, actually. Leave this as entity E and entities. Change E instance of enemy to E instance of missile, and then do ret.add, cast it to a missile to that. So it's going to return that there. So pretty much just doing the same thing as that here, but just returning missiles instead. So we're going to create another method below render. We're going to do private void check collisions. So we're going to go through and we're going to do for enemy E and get enemies. So for every enemy that's in that array, we're going to do for missile M in get missiles. So we're doing an array inside of an array, or I'm sorry, for loop instead of for loop, what am I saying? So first we're going to get each enemy, and then for every single enemy we're going to loop through every single missile, and we're going to see if the if the missile intersects the enemy. So before we can do this, I want you to go back to the entity class, and we're going to create another method here. So we're going to do public rectangle get bounds. And this is just going to be used for checking collisions. So import the badlogic.gdx.math version, and we're going to do return new rectangle. And the 4 parameters it takes is the x position, the y position, and then the width and the height that you want to move it. So it's going to do post.x, post.y, and texture. Actually, we can just do texture dot get width, texture dot get height. So because we set the texture up here to the instance of texture, we can just use that. So it's creating a new rectangle at the position. Say this is the rectangle, or say this is the player right here. We're creating a rectangle from 0, 0, which is that, so the position of the player in this case, over to the width and the height. So W, comma, height, and it's going to create this virtual rectangle right here. And that's going to be the bounding box of how we can check to see if another rectangle intersects or comes into that. So if it does, we know there's a collision. So go back to Entity Manager, and we're going to do if e.getBounds contains m.getBounds. So if the two rectangles touch each other or are inside of each other, then they intersect. So we're going to do entities.remove value. So remove value. It's different from array list. We're going to do e, comma, we'll do false. Pretty much the difference between false and true is true uses, it compares, when it goes through to remove it, pretty much what it does is it compares the value given, so e, to whatever the iteration value is. So say we're on the second iteration, we're going to use, you can either use like if e equals entities dot get I. So say I was a value, say I was a index value, or say it was 2. We can use it and we can see if they're equal. If they're equal, it's going to return true. Or we can do dot equals. Difference between that is the dot equals is more precise. It checks the actual contents of the class itself instead of the class. It's just some other small things. So true is more precise, but in this case we don't need it to be. We can just make it false. It also saves processing speed. So keep it as false for right now. We're also going to do entities.remove value m, so we're going to remove both the entity and the missile at the same time. And then we're going to go up to update, we're going to do check collisions. And that's going to be that. One more thing I want to do is we have to do that whole checking to see if the missile is off the screen. So we're going to do for missile m in get missiles if m dot check end, so if it is off the screen, entities dot remove value m comma false. So it's going to remove it if it's past it. So that's that. So now it should work correctly. Let's see. Boom. There we go. So it's going to be pretty precise, of course. And that's that there. Alright, let me double check something because it looks like the bounding box of the actual entity is a little bit off. I don't know if you guys can tell or not. But when we collide, looks like it's a little off. See how it kind of hits the top and then explodes? Boom. Boom. Let's do, let me just try something really quickly to see if this works. Try that. There we go, it works a little better. Yep, that should work for you. So pretty much going to move it down a little bit, so if it collides a little bit lower, then it's going to give us back that the true value. Now all we have to do is just have to check to see if the player collides with the enemy. So we're going to do if e instance, or I'm sorry, if e dot get bounds dot enter, that's the old one, dot contains player dot get bounds. So if the player and the enemy intersect, we want to pretty much end game lost. After we remove a player, we want to do if game over 1 game, or I guess I could do end game 1. So that's that there. So now what we're doing here is we're going through every single enemy, we're going through each missile for every enemy. If the enemy intersects the missile, we're going to remove both the enemy and the missile. And then after that we're going to see if the enemy size is less than or equal to 0 to see if we killed all the enemies. If we did, then it's game over. After it goes to that, we're going to see if the entity intersects with the player. If it does, it means that we hit it, we lost, game's over. Excuse me. So now what we're going to do, we're going to create a new screen, and we're going to do game over screen. And we're going to do extend screen. And we're going to do, I hate seeing this crap. Alright, now pretty much what we're going to do is we're gonna take the pretty much gonna create a screen. We're gonna create a new camera because the camera's not gonna transfer over. It's quick copy and paste, and then we're pretty much gonna display a picture that says you have lost, and that's gonna be that. So let me go back up here. We're gonna go to the game screen, and we're actually just gonna copy over camera. Copy that over to camera equals new camera, ortho camera. It's pretty much just gonna be a copy and paste for this portion. Camera.update. Oops. We're going to do sb.set projection matrix to the camera.combined, sb.begin, sb.end, camera.resize. Alright, so now we want to do public, we're creating structures for it. Public game over screen, boolean 1. I'm going to go up here, I'm going to do private boolean 1. Actually, we're going to do private texture, texture. I'll show you what I'm going to do here. So pretty much, I created two different pictures that I wanted to add into here. So go down to Android folder, go to Assets, and I have two pictures. So I have the Game Over and the Game 1. So I'm going to drag these, drop them into the Assets folder, and that should be good. So now we're going to go up to the Texture Manager, and we're going to copy and paste this twice. Boom, boom. We're going to do Game Over and Game 1. So Game Over, Game 1. And that's that. So let's go back to the Game Over screen, and we're going to do if 1, then the texture equals texture manager dot game 1, else texture equals texture manager dot game over, and just import the pictures. Oh, we're already good, never mind. So that's gonna be that. Now we're just gonna come down here, and we're gonna do sb.draw, and we're gonna do texture, and then for the x we're gonna do main game dot width divided by 2 minus texture dot get width divided by 2. Explain that in a second. Main game dot get height divided by 2 minus main game dot, minus texture dot get height divided by 2. Pretty much what that's doing is it's taking the center of the screen, and then it's going to subtract the half the size of the texture. So say the texture is 200 pixels, it's going to move it down 100, and then it's going to make it seem centered in the middle of the screen. On the X, or on, that's going to be on the Y. So say it's 200 up and down, it's going to move it down. It's going to subtract it 100 from the height, so it's going to make it centered. For the X, it's going to go to the center of the screen, and then it's going to divide the width into 2, and then subtract that amount, so the center of the picture is going to be in the center of the screen. So that's not too difficult. Hopefully you guys understand that. Alright, so this pretty much should be good. We're going back to Entity Manager. After the if game over, we're just going to do screen manager dot set screen, new game over screen, and we're going to do 1 because that means that they won. So import that. Oops, I'm sorry. Said it's true, not 1. I'm going to copy this line here, come down to here, and just paste it, and we're set this to false, which pretty much means that they lost. So let's try it out. It should work like a charm. Alright, so we're going to fire. Let's try and win first. Let's see if I can do it. Oh no. Gotta set bounds so we can't go outside of it, of course. You can always bump up the speed of the missiles too if you find them too slow. Alright, so, that's because we have to go up here, like I said, do, in the create, do camera.resize. For some reason it doesn't display the actual game for some reason once the camera's set, or once the projection matrix is reset, so we have to do resize in the create method. So just put that there and it will fix that issue. Let's go back up here. Something's wrong with the bounding box, so I'm trying to figure out that issue. Clearly, because a person just went through our player. Game over, you have won. So that's it there. Now let's find out what's wrong with this bounding box. Entity, and I'm gonna remove this because I think this is just screwing it up. Texture.getWidth, texture.getHeight. No problems there. Let's try and lose. Alright, give me 1 second. I'm going to try and figure this. So the problem is pretty simple. I just used actually the wrong method to check for collisions. Instead of, oops, let me change this. We had contains here. Changed contains to overlaps. That was my fault. So the actual, what contains the actual whole rectangle has to be inside of the other rectangle, which is pretty much close to impossible, except with the missile. So the missile has to be inside of it, which isn't too hard. But overlaps just checks to see if they touch, so I used the wrong one by mistake. So now if you run it, it should work perfectly fine. So I'm going to kill a bunch of them, they'll see them intersect automatically, and we should win. Where's that last guy? Come on. Alright, game over, you have won. Let me move that. Now let's try and lose. Shouldn't be too hard. Game over, you have lost. So that is the game. We are officially done it. Now one of the things that we can do is we can add in a add it in so that it works for Android as well. So what we're going to do is we're going to do that very, very quickly. If you go to the player, pretty much we're just going to comment out actually we actually do this. After the if the A key is pressed, do or. So if it's pressed or, gdx.input is touched. Sorry, delete this. I have to think about how to do this. Okay, we're gonna do boolean left, which equals false. We'll do true. So what we're going to check to see is if the finger touch on the screen is going to be to the left of the screen or to the right. So if the mouse or the person touches to the left of the player or to the right of the player, then it's going to move them to the left or the right. When they let go, it's going to stop them. So we're going to do if gdx.input.is touched, and then we're pretty much just going to do if gdx.input.is or .get x, and one of the things we have to have for this, we have to have the camera. So do ortho, I'll explain why in a second. Do ortho camera. Now this is going to make it a little bit more complicated, I know. I have to change a few things, but if I actually have to change this. I'll come back to this in a second. Now, like I was saying, remember how I was saying with the whole camera thing, how you have to change we have to do this. We're going to create a new, let me think about how to do this. Alright, let me think about this. We're going to remove this. The whole thing with what I'm trying to do is when a person touches the screen, it touches them and it gives you the X and Y position relative to their phone. So if their phone, like I said, is 1200 by 720, that's outside the range of our game dimension. So it's going to give us those X values and Y values, but it's not going to be within those Y values and X values. So we have to have the camera to be able to convert those values to the values that are on the screen. So it's going to be between our width and our height. So we would do camera unproject coordinates, and we just do that. We do X and Y. So gdx.input.get X, and then gdx.input.get Y, and it's going to return a vector2 value. Alright, so like I said, we'll come back to this portion later. If the screens touch, we're going to get the coordinates and we're going to unproject them. So we're getting X and Y where it touched. We need to do this because if the screen's bigger than our game, then we need to pretty much, what it's going to do is it's going to scale them down to the screen size for our game, to the game size. And it'll give us the coordinates relative to that. So I can also demonstrate that to you. I can print out the differences. So do touch, and then plus. That's going to print out the vector2 automatically. They have a get string method. Then we're going to do gx.input.getx, and plus gx.input.get. You don't have to do this, I'm just doing this for demonstration purposes. We just have to find an efficient way to transfer the camera. The reason it's giving me an error is because we didn't actually implement the update method. We actually did something different. So let me think about how to do this. We're going to do... Alright, we're going to come down here, we're going to go down to the player, add this unimplemented method. It's pretty much going to create a new instance, or I'm sorry, a new method called update without this inside of it. Now it's going to be kind of ugly, I know, but we're going to have to leave it like that just for now. So just leave this empty. We're going to come up to here, we're going to go to Entity Manager, and inside of the constructor of Entity Manager, we're going to do ortho camera o. Oh, you know what? It's even a better idea, I'm sorry. Go back to player, remove this, put back the at override. So pretty much just go back to where we were at last. Make it like this. Then do private final ortho camera. And here do ortho camera. And import that. I want to do this dot camera equals camera. So we're just going to create a new instance of it in here, and then we can get use of it in this portion. And here, in the constructor of Entity Manager, add it so that we need an ortho camera for the parameter. And at the end of the creating the new player object, just do camera. So it's giving our player the camera. So now, let's go back to game screen, change this to camera. And now technically it should work as well. So if we click to the left, as you can see, it's going to show me the values. So the ones in the brackets are going to be the values of our game. The ones on the right are going to be the values of the actual screen. So it's a difference. On Android phones, as you can see, it's 673. So this X value is right, but the Y value is wrong, because in Android they flip it, so it's actually flipped. So this is going to be the bottom, and that would be the top. So let me show you again. Up here is the top. So as you can see, -3, 47. It's very weird. So what it does is it converts it down to the libgdx's coordinates and to our game coordinates. So it makes it smaller for us. Now go back to the player, and we're pretty much just going to do if touch.x is less than main game.height. .width divided by 2. So if it is to the left of the width, so say this is our screen, the center is right here. If it is to the left of it, we're going to make left equal to true, otherwise it's going to be to the right, and we're going to move it to the right. So that's how we can tell. So we're going to do if it's to the, actually we're going to do greater than, reason being, if the x is greater than, so if it's to the right, like I said, then we're going to set left equal to false. Now we're just pretty much going to use that Boolean value down here. So now we're going to do or left, and then or not equal to left. So if A is pressed, or we touched it to the left of the screen, so left is equal to true, then we're going to move it to the left. Otherwise, if D is pressed and it's not moved to the left, so left is equal to false, which it is if we press to the right of the screen, it's going to move it to the right. Otherwise, set the direction equal to nothing. Actually, now I think of that, it's not going to work correctly. Change this to an integer value. Change this to 0. Change this to direction. I'll explain why in a second. Change dir equal to 1, else dir equals 2. Dir equals 1, dir equals 2. Okay, what was the reason I did that for? Alright, so before we had Boolean left is equal to true. Now because it's equal to true, every single time it's called, it's going to move it to the left regardless of whether or not you're pressing it. So pretty much if we need to make it two different values. So if dir is equal to 1, move to the left. Otherwise, if it's equal to 2, move it to the right. Otherwise, if it's still equal to 0, so if it was never touched, then set the direction equal to 0, 0, so it's not moving to the left or the right. Now we should be able to move it to the left and the right using the key press. Oops, we switched it by accident. Make this 2. Make this 1. So we click, and this should work on Android as well for those of you trying it. And we should work. Now, another thing that we can do is, because you can't press the spacebar on the actual Android itself, comment out that line and then the brace at the end. Change this to, I don't know, 350. And what it's going to do is it's automatically fire now, so we don't have to worry about having to press it. So now this should work on the Android version perfectly fine with no issues whatsoever. If you do have issues in any of this code, please let me know. I am going to be posting the source code onto GitHub along with all the pictures, so you should have no problem grabbing those. And if you have any questions, comments, suggestions, if you just want to thank me for creating this, then I would be more than happy to reply to you and say thanks. So I hope you guys liked the tutorial. Let me know what you think, and make sure to subscribe. Thanks for watching, guys. Take it easy. I'll see you later.